In April 1942, the captured American reconnaissance car sits in a Japanese depot, mud still caked on its 6 and 16 tires. To Colonel Tetsuo Iwakuro, examining the crude, welded steel body, the machine looks almost insultingly simple. 250 lobby of blunt American engineering. His Type 95-pont Kurigane scout cars by comparison are mechanical poetry. Precision machine components, elegant solutions, 4,700 units crafted with meticulous attention to detail. Toyota's Kichiro Toyota receives the Imperial Army's directive with quiet confidence. Design and build a Japanese equivalent to the American vehicle. Target completion 6 months. His engineers gather around the disassembled machine, seeing opportunity everywhere. The American suspension too heavy. The transmission unnecessarily robust. The body panels thick enough to armor a tank. "We can build this better," Toyota declares. Lighter, more efficient, more reliable. But when the material allocation arrives, 2.1 tons of steel for 6 prototypes. The numbers don't make sense. The American vehicle uses 1.4 tons per unit. Even with Japanese efficiency, the math is impossible. Japan tried to copy the American Jeep, but they were about to discover something that would change everything they believed about manufacturing forever. The weight of the captured American vehicle became Kichiro Toyota's obsession through the spring of 1944, 2,450 lb of what his engineers dismissed as crude American engineering. Yet something about its brutal simplicity nagged at him. Every morning he walked the Como plant floors where Toyota's craftsmen assembled their Type KC trucks, with the precision of watchmakers. Each component hand-fitted, each weld inspected, each measurement precise to the millimeter. Chief designer Kazu Kumab spread the American vehicle's technical drawings across his desk, like a surgeon examining X-rays. The frame rails used 14-gauge steel, thick, heavy, wasteful. The suspension components looked like they'd been forged by a blacksmith rather than machined by engineers. The transmission housing could have been half the weight with proper Japanese engineering techniques. "Look at these welds," Kumab said, tracing his finger along the photographs. A first-year apprentice could do better. His team of 12 senior engineers nodded in agreement. Toyota had spent decades perfecting manufacturing techniques that produced vehicles of extraordinary precision. Their Type 95 Kurigane scout cars represented the pinnacle of Japanese automotive engineering, 4,700 units built since 1936, each one a masterpiece of mechanical efficiency. Shoichiro Toyota, 22 years old and eager to prove himself worthy of the family name, calculated the improvements they could achieve. Reduce frame weight by 23% through better steel selection. Improve fuel efficiency by 18% with a lighter transmission. Increase reliability by 30% through superior electrical systems. The numbers painted a picture of inevitable Japanese superiority. The AK-10 project launched with typical Toyota methodical precision. Kichiro assembled his best team. Kumab for design excellence, production manager Hiroshi Nakamura for manufacturing efficiency, and his son Shoiro for systems integration. Their target specifications exceeded the American original in every measurable category. Weight 1890 lb versus the American's 2450. Fuel consumption 18.7 liters per gallon versus 14.2, ground clearance 9.2, 2 versus 8.5. But the first crack in their confidence appeared in Nakamura's material requisition office on a gray April morning. The supply manager's weathered face carried bad news even before he spoke. Steel allocation for the AK-10 project, 2.1 tons monthly. Rubber allocation enough for 12 tires total. Copper wiring allocation 14 lb. Toyota stared at the numbers, his engineering mind automatically calculating the impossibilities. The American vehicle consumed 1.4 tons of steel per unit. Even with Japanese efficiency improvements, building 6 prototypes would require at least 4 tons of material. The mathematics were undeniable and devastating. There must be an error, Toyota said, though he already knew better. Japan's industrial capacity was bleeding resources to more critical military priorities. Steel went to destroyer hulls and submarine pressure vessels. Rubber went to aircraft tires and tank treads. Copper went to electrical systems for radar installations and naval communications. Nakamura pulled out production reports that painted an even grimmer picture. Japan's total military vehicle production across all manufacturers, 88,000 units annually. America's Ford Motor Company alone had produced 277,000 vehicles in 1943. The scale difference wasn't incremental. It was civilizational. Yet Toyota's engineers pressed forward with characteristic determination. If they couldn't build with abundant materials, they would build with superior intelligence. Komabe redesigned the frame using 16-gauge steel instead of 14, compensating for reduced strength through geometric optimization. The transmission shed 47 lbs through precision engineering, while gaining an additional gear ratio. Every component reflected decades of Japanese manufacturing refinement. The first prototype emerged from Toyota's assembly halls on July 15, 1944. Like a mechanical haiku, elegant, efficient, perfectly balanced. Test performance exceeded every specification. The vehicle climbed 45-degree slopes that stopped the heavier American original at 38 degrees. Its fuel efficiency numbers vindicated Japanese engineering philosophy. Precision over brute force, intelligence over abundance. Colonel Iwakuro arrived for the demonstration with a procurement committee of Imperial Army officers who expected to witness Japanese industrial superiority in action. The AK-10 performed flawlessly through mud tests, steep gradient climbs, and obstacle courses that would challenge vehicles twice its weight. Every system functioned with clockwork precision. "Excellent work," Uwaro declared, making notes in his leather portfolio. "How many units can you deliver by December?" The question Toyota had dreaded most. He'd prepared his answer through weeks of production calculations that grew more depressing with each iteration. With current material allocations, approximately 50 vehicles. The silence in the demonstration area felt like a physical weight. Iwakuro's pen stopped moving. 50 vehicles total? Yes, sir. Current steel and rubber allocations limit our production capacity to roughly 8 units monthly through the remainder of the year. Iwakuro set down his portfolio and fixed Toyota with the stare of a career military officer, accustomed to overcoming impossible obstacles through sheer determination. The Americans are producing 600 Jeeps per day. 600 per day? The number hit Toyota's engineering team like artillery fire. That meant 19,000 units annually from a single vehicle type. Toyota's entire automotive production in 1943 had totaled 16,032 vehicles across all models. In the privacy of Toyota's office, Iwakuro revealed the full scope of Japan's industrial crisis. Steel production is down 37% from peak levels. Rubber imports have ceased entirely. We're operating on stockpiles. Every copper wire in this factory could be better used in submarine electrical systems. Toyota requested a meeting with supply coordination officers, hoping to negotiate increased material allocations. His presentation was methodical and compelling. 200 AK-10 vehicles monthly would require 47 tons of steel, 4,000 tires, and 180 skilled machinists. The specifications were precisely calculated and completely impossible. "We have 8.2 tons of steel available monthly," the coordination officer explained with bureaucratic patience. 200 tires maximum allocation, 23 skilled machinists currently unassigned to essential war production. The mathematical reality crushed Toyota's ambitions with the weight of industrial physics. They could build perfect vehicles or they could build adequate quantities. But Japan's resource base made both simultaneously impossible. American production philosophy suddenly made terrible sense. Good enough, fast enough, cheap enough. Build 600,000 acceptable Jeeps rather than 6,000 perfect ones. Walking through the Como plant that evening, Kichiro Toyota finally understood what the captured American vehicle had been trying to tell them. Its crude welds and heavy construction weren't design flaws. They were production features, built for manufacturing speed rather than engineering elegance, designed for 10,000 factories rather than 10 master craftsmen. Japan had spent decades perfecting the art of building individual vehicles. America had perfected the science of building vehicle production systems. In industrial warfare, the side that built more would defeat the side that built better, no matter how much better their products might be. The AK-10 prototype took shape through April and May of 1944, like a mechanical sculpture carved from scarcity. Every line on Kazuokumab's blueprints represented a compromise between engineering ambition and material reality. The original frame specification called for 14-gauge steel rails that would provide structural integrity comparable to the American original. Available material 16-gauge steel that reduced load-bearing capacity by 23%. Shoiro Toyota spent sleepless nights in the engineering halls, slide rule and calculating machine working through stress analysis that would compensate for weaker materials through superior design. His solution was elegant in its complexity. A triangulated frame structure that distributed loads through geometric precision, Rather than brute material strength, the mathematics were flawless. The manufacturing requirements were punishing. Each frame joint required 17 individual welds performed to tolerances measured in fractions of millim. A single misaligned connection would cascade structural weaknesses throughout the entire vehicle. Toyota's master welders, craftsmen who'd spent decades perfecting their art, could complete one frame per week working 12-hour shifts. American production lines, according to intelligence reports, stamped and welded Jeep frames in 47 minutes using semi-skilled workers and automated jigs. The transmission presented an even more sophisticated challenge. The American Bantam used a simple 3-speed manual gearbox that weighed 112 lbs and could be manufactured by any competent machine shop. Kumab's team designed a 4-speed transmission with synchro mesh gearing that weighed 65 lbs and delivered smoother power delivery across a broader range of operating conditions. The weight savings were substantial. The complexity increase was exponential. Manufacturing the new transmission required 47 precision machine components, each one held to tolerances that demanded Toyota's most experienced machinists. The gear teeth alone required 18 hours of hand finishing per transmission unit. American Jeep transmissions, crude as they appeared, used standardized components that could be mass-produced on automated equipment by workers with minimal training. Rubber allocation arrived in May with the bureaucratic precision that characterized Japan's resource management crisis. 12 tires total for the entire AK10 development program. Prototype testing would be limited to essential functionality verification, no endurance runs, no extended field trials, no margin for error or equipment failure. Nakamura calculated the rubber mathematics with grim efficiency. Each AK10 required 4 operational tires plus 1 spare. Testing 3 prototypes simultaneously would exhaust their entire rubber allocation, leaving no reserves for the remaining 3 vehicles, or replacement tires if testing revealed design problems. American Jeep production consumed $18,000 tires daily across all manufacturing facilities, yet progress continued with characteristic Japanese determination. The AK-10's projected specification exceeded American performance in measurable categories that mattered to military effectiveness. Fuel efficiency 23% improvement over the Bantam original. Power-to-weight ratio 18% better through engine optimization and structural weight reduction. Ground clearance improved by 1/8 of an inch through suspension redesign. Electrical systems showcase Toyota's technological sophistication. While American Jeeps use simple 6-volt systems with minimal instrumentation, the AK-10 featured a 12 VT electrical architecture that powered comprehensive engine monitoring, improved lighting systems, and radio integration designed for Japanese military communication standards. The wiring harness alone contained 237 individual connections, each one hand-soldered and wrapped in insulation that would resist moisture, vibration, and temperature extremes. Building these electrical systems consumed Toyota's entire monthly copper allocation for May and most of June. Each vehicle required 14 lb of copper wiring, compared to the American Jeep's 8 lb of Crutter electrical components. The superior performance was undeniable. Their source consumption was devastating. Kumab stood before the first completed prototype mock-up in early June, pride and anxiety wearing in his methodical engineer's mind. Every component represented the pinnacle of Japanese automotive engineering. The hand-pished aluminum engine block weighed 37 lbs less than the American cast-iron equivalent, while delivering superior performance through precision manufacturing. The suspension components were machined to tolerances that eliminated play and vibration. While reducing weight by 42 lb, the vehicle was a masterpiece of mechanical engineering, and Kumab understood with growing clarity that masterpieces were Japan's fundamental strategic weakness. American intelligence reports filtered through military channels and decoded by Toyota's production analysis team revealed the true scale of Allied industrial capacity. Willys Overland's Toledo plant employed 1896 workers who produced 442 completed Jeeps daily. Ford's River Rouge complex had dedicated assembly lines that could manufacture 600 vehicles per shift, using standardized components and interchangeable parts. The production mathematics were staggering in their implications. American Jeep manufacturing cost $648 per unit through mass production techniques that prioritized quantity over individual vehicle perfection. Toyota's AK-10 projected manufacturing cost $2,100 per vehicle, assuming they could somehow obtain unlimited materials, and expand their skilled workforce by 300%. Shichiro brought these calculations to his father's attention through a presentation that laid out Japan's industrial reality with mathematical precision. Current Toyota production capacity: 47 skilled machinists, 12 master welders, 6 precision engine builders. Required capacity for meaningful AK-10 production: 180 machinists, 60 welders, 30 engine specialists, plus dedicated assembly line infrastructure that would require 8 months to construct and commission. Training replacement workers to Toyota's quality standards required 18 months of apprenticeship under master craftsmen who were already working beyond sustainable limits. American production lines, according to decoded reports, trained semi-skilled workers to perform specialized assembly tasks in 2 to 3 weeks using standardized procedures and automated tooling. The prototype testing phase revealed both the triumph and tragedy of Japanese engineering excellence. The AK-10 outperformed the captured American vehicle in acceleration, fuel economy, handling precision, and component reliability. Independent military evaluators praised its superior build quality, noting that panel gaps were measured in fractions of millimeters, and mechanical tolerances approached Swiss chronometer precision. But each test consumed irreplaceable resources. Tire wear analysis required rotating the limited rubber allocation between vehicles, preventing simultaneous testing of multiple prototypes. Fuel consumption measurements depleted gasoline reserves that took weeks to replenish through Japan's strained logistics network. Component failure analysis meant Honda rebuilding specialized parts that American factories would simply replace from warehouse inventory. By late June, Toyota had completed 3 AK-10 prototypes that represented individual triumphs of engineering artistry. Each vehicle embodied 47 years of Japanese automotive development, incorporating lessons learned from building everything from silk-weaving machinery to aircraft engines. They were demonstrably superior to their American counterparts in every measure of individual quality and performance. They were also impossible to manufacture in militarily significant quantities using Japan's available industrial resources, skilled workforce, and raw material allocations. Kumabe's perfect engineering had created perfect vehicles for an imperfect war. American crude effectiveness was defeating Japanese refined excellence through the simple mathematics of industrial capacity multiplied by time. The lesson was becoming undeniable. In mechanized warfare, adequate quantities defeated superior quality, no matter how superior that quality might be. The first complete AK-10 rolled out of Toyota's assembly hall on July 15, 1944 at 11:30 in the morning. 340 man-hours of skilled labor had transformed raw materials into a vehicle that represented everything Japanese engineering could achieve under wartime constraints. Every component had been hand-fitted by master craftsmen. Every weld had been inspected under magnification. Every measurement had been verified to tolerances that would have impressed Swiss clockmakers. Shoiro Toyota climbed behind the steering wheel for the initial test drive, feeling the precise engagement of the clutch and the smooth mesh of gear ratios that had consumed months of development time. The engine responded with mechanical poetry. No vibration, no idle, no uneven power delivery. The steering tracked perfectly straight without constant correction. The suspension absorbed road irregularities without transmitting harshness to the cabin. Performance testing began immediately on Toyota's proving grounds, a compact facility that had been carved from agricultural land behind the Kamo plant. The AK-10 climbed a 45-degree slope that had stopped the heavier American Bantam at 38°. Fuel consumption measurements showed 18.7 min-hours per gallon, compared to the American vehicle's 14.2 acceleration from 0 to 30 mph, 12.4 seconds versus the Bantam's 16.1. Every metric confirmed Japanese engineering superiority. The AK-10 was lighter, more efficient, more responsive, and more refined than its American counterpart. Kumabe watched the testing with satisfaction that was tempered by growing awareness of what these achievements actually meant in the context of global industrial warfare. Colonel Iwaro arrived on July 20th, with a full procurement committee and expectations shaped by years of Japanese technical excellence. The demonstration proceeded flawlessly through mud courses, steep gradients, and obstacle navigation that showcased the AK-10's superior agility. The vehicle performed with mechanical precision that impressed even experienced military engineers who had tested countless pieces of equipment. "Outstanding work," Iwakuro declared, making detailed notes about performance specifications that exceeded requirements. "This vehicle represents the finest reconnaissance platform our forces have seen." When can production begin? The question that had haunted Katiro Toyota through weeks of sleepless calculation. "With current material allocations and manufacturing capacity, we can deliver approximately 50 units by year-end." Iwakuro's pen stopped moving. The procurement committee exchanged glances that conveyed months of frustration with Japan's industrial limitations. 50 vehicles for the entire Imperial Army. Current steel allocation permits 8 vehicles monthly through December. Toyota explained with the precision of an engineer, delivering unwelcome mathematics. Rubber allocation limits tire production. Skilled workforce availability restricts assembly line capacity. The colonel closed his notebook and requested a private discussion. In Toyota's office, away from the engineering team, Iwakuro revealed production reports that painted a comprehensive picture of Allied industrial capacity. American Jeep production had reached 600 units daily across multiple manufacturing facilities. Ford Motor Company alone was producing more military vehicles monthly than Japan's entire automotive industry manufactured annually. 600 per day, Iwakuro repeated, the number hanging in the air like artillery smoke. That's 219,000 vehicles per year from a single vehicle type. The mathematics were devastating in their implications. Toyota's total automotive production in 1943 had been 16,32 vehicles across all civilian and military models. America was producing more Jeeps in 3 weeks than Japan built vehicles in 12 months. Toyota requested detailed material requirements for scaled production, hoping to identify bottlenecks that could be addressed through resource reallocation. Manufacturing 200 AK10 vehicles monthly would require 47 tons of steel, 4,000 rubber tires, 180 skilled machinists, and dedicated assembly line infrastructure currently used for essential truck production. Current allocations: 8.2 tons of steel monthly, 200 tires maximum, 23 available machinists. The gap between requirement and availability wasn't incremental, it was categorical. Japan's industrial base couldn't support meaningful AK-10 production without abandoning other critical military manufacturing. Nakamura presented a comprehensive analysis of American production, methodology based on decoded intelligence, reports and captured equipment documentation. Willys Overland's Toledo plant employed 1896 workers organized into specialized assembly teams. Each worker performed specific repetitive tasks using standardized tools and procedures. Component manufacturing relied on automated machinery that could produce thousands of identical parts with minimal skilled oversight. American Jeep production cost $648 per unit. Toyota's AK-10 manufacturing cost $2,200 per vehicle, assuming unlimited materials and expanded workforce. The price differential wasn't about profit margins. It reflected fundamental differences in production philosophy. American manufacturing prioritized standardization over optimization. Jeep components were designed for mass production rather than individual excellence. Tolerances were adequate rather than precise. Materials were abundant rather than efficient. The entire system was engineered for quantity production by semi-skilled workers using automated equipment. Japanese manufacturing traditions emphasized individual craftsmanship and component optimization. Each AK-10 represented the accumulated expertise of master mechanics who had spent decades perfecting their skills. Quality standards exceeded functional requirements because excellence was considered inherently valuable. The approach produced superior individual vehicles at costs that made mass production impossible. Intelligence reports revealed the scale of American industrial mobilization with mathematical precision that was impossible to dismiss. Ford's River Rouge complex had converted automobile assembly lines to produce B-24 bomber components, Jeep engines, and tank transmissions simultaneously. Chrysler Corporation was manufacturing complete Sherman tank powertrains using automotive production techniques adapted for armored vehicle requirements. The numbers painted a picture of industrial capacity that dwarfed Japan's entire manufacturing base. American steel production, 89 million tons annually. Japanese steel production, 7.8 million tons. American aluminum production, 920,000 tons. Japanese aluminum production, 142,000 tons. American automotive industry workforce, 460,000 skilled and semi-skilled workers. By August, Toyota had completed all 6 AK-10 prototypes, each one requiring specialized attention from engineers and craftsmen who could have been building essential military equipment. Quality control had rejected 0 components, a manufacturing miracle that demonstrated Japanese technical excellence while highlighting the impossibility of scaled production. Each prototype represented different optimization approaches: weight reduction, fuel efficiency, component simplification, manufacturing cost reduction. None of the variations addressed the fundamental problem of industrial capacity constraints that made mass production impossible, regardless of engineering excellence. The final prototype testing revealed performance that exceeded every specification, while consuming resources that Japan couldn't afford to invest in vehicle development. Tire wear analysis had exhausted rubber allocations. Fuel consumption measurements had depleted gasoline reserves. Component durability testing had consumed machine shop capacity needed for aircraft engine manufacturing. Shoiro presented his father with production scaling calculations that laid out the mathematical impossibility of meaningful AK-10 manufacturing. Current Toyota capacity could theoretically produce 96 vehicles annually using every available resource. American Willys Overland was producing more Jeeps in 4 days than Toyota could manufacture in 12 months. Using their entire industrial infrastructure, the lesson was becoming undeniable through arithmetic that no amount of Japanese determination could overcome. Superior individual products were irrelevant if you couldn't produce enough of them to influence military outcomes. American crude effectiveness was defeating Japanese refined excellence through the simple mathematics of industrial capacity, multiplied by time, multiplied by available resources. In mechanized warfare, the side that built more vehicles would defeat the side that built better vehicles, regardless of how much better those vehicles might be. By the end of July 1944, Toyota's engineering halls displayed 6 completed AK-10 prototypes like mechanical trophies in a museum of impossible ambitions. Each vehicle embodied 340 man-hours of skilled craftsmanship, representing the accumulated expertise of Japan's finest automotive engineers applied to a single reconnaissance vehicle design. Quality control statistics told the story of Japanese manufacturing excellence. 0 rejected components, 0 assembly defects, 0 performance failures during initial testing. The mathematics of mass production told a different story entirely. Production manager Nakamura spread his scaling analysis across the conference table where Toyota's leadership gathered for what everyone understood would be a final assessment of the AK-10 program. The numbers were precise, comprehensive, and devastating. Manufacturing 1,000 AK-10 vehicles monthly would require 47 tons of steel, when current allocation provided 8.22 tons, 4,000 rubber tires when allocation permitted 200, 180 skilled machinists when 23 were available, a dedicated assembly line when existing facilities were committed to essential KC truck production that supplied Japan's dwindling logistics network. We can build perfect vehicles, Nakamura concluded with the measured precision of an accountant delivering a death sentence. We cannot build enough vehicles to matter. Kumab studied photographs of American production facilities that had been obtained through military intelligence channels. Willys Overland's Toledo plant stretched across acres of factory floor where 1896 workers produced 442 completed Jeeps daily using assembly line techniques that prioritized speed over individual craftsmanship. Each worker performed specialized tasks that could be learned in 2 to 3 weeks rather than the 18-month apprenticeships required for Toyota's quality standards. The American production model relied on interchangeable components, manufactured to adequate tolerances rather than optimal precision. Jeep frames were stamped from standard steel sheets and welded using automated jigs that ensured consistent results without requiring master craftsmen. Engines used cast iron blocks that were heavier than Toyota's precision-machined aluminum, but could be mass-produced using foundry techniques that demanded minimal skilled labor. Ford's production statistics revealed the true scale of American industrial capacity. Their River Rouge complex alone employed 95,000 workers, who could be rapidly retrained for different manufacturing assignments as military priorities shifted. Automotive assembly lines had been converted to produce aircraft engines, tank transmissions, and artillery shells using the same standardized production techniques that made civilian vehicle manufacturing so efficient. American Jeep production costs reflected this industrial approach, $648 per unit through manufacturing systems designed for quantity, rather than individual excellence. Toyota's AK-10 production cost calculations showed $2,100 per vehicle, assuming unlimited materials, and a threefold expansion of their skilled workforce that would require years to train and decades to master Toyota's exacting standards. The resource allocation meeting in early August provided the final confirmation of Japan's industrial limitations. Steel production had declined to 7.88 million tons annually as raw material imports dwindled and mining capacity was redirected to more critical military applications. Rubber stockpiles were approaching depletion, with no possibility of synthetic replacement at scales required for vehicle production. Copper allocation prioritized naval vessels, aircraft electrical systems, and communication equipment over automotive applications. Colonel Iwaro attended the meeting with procurement officers who carried detailed comparisons between Japanese and American production capacity. The numbers were classified but undeniable. America's combined automotive manufacturers were producing 2.6 million military vehicles annually across all categories. Japan's entire automotive industry, including Toyota, Nissan, and smaller manufacturers, had produced 88,000 military vehicles in 1943. The scale difference wasn't incremental. It represented fundamentally different approaches to industrial warfare. American manufacturing philosophy emphasized adequate quality produced in overwhelming quantities. Japanese traditions prioritized superior individual products that required resources and craftsmanship. Japan could no longer afford to invest in vehicle development. Intelligence reports from the Pacific Theater provided context for these production disparities. American forces were receiving continuous equipment, replacement and upgrading, while Japanese units operated with vehicles that had been in service since the war's early months. Maintenance became increasingly difficult as spare parts grew scarce and replacement vehicles became unavailable. Superior Japanese engineering was being defeated by American logistical abundance. Quairo presented his comprehensive analysis of global automotive production to Toyota's senior leadership in a presentation that laid out the mathematics of industrial defeat. American manufacturers had retooled automobile assembly lines to produce military equipment using mass production techniques that Japan had never developed at meaningful scale. Ford, General Motors, and Chrysler combined employed more workers in automotive manufacturing than Japan's entire heavy industry workforce. The AK-10 program represented Japan's fundamental strategic misunderstanding of industrial warfare. Superior individual products were militarily irrelevant if they couldn't be produced in quantities sufficient to equip fighting forces. American Jeeps might be crude by Japanese engineering standards, but 600,000 crude vehicles would defeat 6,000 perfect ones through simple arithmetic of battlefield presence. By mid-August, the contradiction between Japanese engineering excellence and industrial reality had become impossible to ignore. Toyota's 6 AK-10 prototypes performed flawlessly in every test, demonstrating superior fuel efficiency, climbing capability, mechanical reliability, and overall refinement compared to captured American vehicles. They also consumed Japan's entire monthly allocation of automotive raw materials while producing 6 vehicles that couldn't meaningfully impact military operations. American production philosophy suddenly made strategic sense viewed through the lens of resource allocation and manufacturing scalability. Crude but adequate vehicles could be built quickly by semi-skilled workers using standardized components and automated assembly techniques. Design optimization focused on manufacturability rather than individual performance. Component tolerances prioritized interchangeability over precision. The entire system was engineered for maximum production volume using available industrial capacity. Japanese manufacturing traditions that had produced automotive excellence in peacetime became strategic liabilities in global industrial warfare. Master craftsmen who could build perfect engines were irreplaceable resources that required decades to develop and couldn't be rapidly scaled to meet wartime production demands. Precision manufacturing techniques that produced superior individual vehicles consumed resources that could have equipped multiple adequate units using American production methods. The final blow came on August 14th when B-29 Superfortresses appeared over the Kamo plant at 11:47 in the morning. The bombing attack destroyed 23% of Toyota's manufacturing capacity, including machine shops where AK-10 components had been precision manufactured by irreplaceable master craftsmen as months of Development work disappeared in 18 minutes of high explosive devastation. Standing in the smoking ruins of his factory, Kiichiro Toyota finally understood the fundamental lesson that had eluded Japanese industrial leadership throughout the war. They had built better individual vehicles using superior engineering and manufacturing techniques. America had built better production systems that could overwhelm superior individual products through sheer volume and industrial capacity. The captured American Bantam still sat in the depot courtyard, functional after 3 years of examination and testing. Its screwed welds and heavy construction represented design philosophy that prioritized mass production over individual excellence. 600,000 adequate vehicles would defeat 6,000 perfect ones every time, regardless of how perfect those vehicles might be. Japan had lost the war in Detroit's assembly plants long before the first shot was fired in the Pacific. 5 days after Emperor Hirohito's surrender announcement, Kiichiro Toyota sat alone in his office with the AK-10 project files spread across his desk, like archaeological evidence of Japan's industrial delusions. Outside his window, the captured American Bantam remained in the courtyard where it had sat for 3 years. Its crude construction, now telling a different story than Japanese engineers had understood in 1942. The mathematics of defeat lay before him in precise columns of numbers that documented every stage of the AK-10 program. 6 prototype vehicles completed at a total cost of $47,000, using materials that could have built 37 essential KC trucks for Japan's collapsing logistics network. 340 man-hours of skilled labor per vehicle, when American assembly lines produced Jeeps in 2.66 hours using semi-skilled workers and automated equipment. Each AK-10 represented everything Japanese engineering could achieve under wartime constraints. Superior fuel efficiency, reduced weight, improved climbing capability, mechanical refinement that exceeded American standards in every measurable category. They were demonstrably better vehicles built by demonstrably better engineers using demonstrably superior manufacturing techniques. They were also strategically meaningless in a war decided by industrial capacity, rather than individual product excellence. Toyota opened his leather-bound wartime journal and wrote what he knew would be his final entry about the project that had consumed 18 months of Toyota's best engineering talent. We believed superior craftsmanship could overcome industrial capacity. We were wrong. In modern warfare, the side that builds more wins, not the side that builds better. The Americans understood something we missed. Perfect engineering means nothing without perfect logistics. The numbers told the complete story with mathematical precision that no amount of Japanese determination could overcome. American Jeep production from 1941 to 1945, 634,569 units. Japanese AK-10 production over the same period, 6 prototype vehicles that had never seen combat deployment. American factory capacity had been designed for volume production, using standardized components and interchangeable parts. Japanese manufacturing capacity had been optimized for individual excellence, using master craftsmen and precision techniques. Kiichiro entered his father's office carrying production reports from Allied industrial surveys that were beginning to reveal the true scale of American manufacturing capability. Ford Motor Company's Willow Run plant had produced 18,635 bombers using automotive assembly line techniques adapted for aircraft. Manufacturing General Motors had converted Cadillac factories to produce tank engines and artillery shells while maintaining civilian automobile production at reduced levels, Father Shoiro said, setting the reports in the desk beside the AK-10 files. We learned the wrong lesson from the Americans. We tried to copy their vehicle. We should have copied their method. The insight that would reshape Toyota's understanding of industrial production lay in that simple observation. American success hadn't come from superior engineering. Their Jeeps were demonstrably inferior to Japanese prototypes in performance, efficiency, and build quality. American victory had come from superior production systems that could build adequate vehicles in overwhelming quantities using available resources and workforce. Kiichiro studied photographs of American assembly lines where workers performed specialized tasks using standardized tools and procedures that could be learned in weeks rather than the decades required to master traditional Japanese craftsmanship. Component manufacturing relied on automated machinery that produced thousands of identical parts with tolerances that were adequate rather than optimal. The entire system prioritized manufacturability over individual product excellence. Japanese manufacturing philosophy had emphasized continuous improvement of individual products through master craftsmen who spent lifetimes perfecting their skills. Each vehicle represented the accumulated expertise of engineers and workers who treated manufacturing as an art form, requiring personal dedication and technical mastery. Quality standards exceeded functional requirements because excellence was considered inherently valuable regardless of cost or production efficiency. The contradiction between Japanese values and wartime necessity had doomed the AK-10 program from conception building. Better vehicles required resources that Japan couldn't afford to invest in automotive development. Training better craftsmen required time that industrial warfare didn't permit. Achieving better individual quality consumed materials that could have equipped multiple adequate units using American production methods. Walking through the bombed Como plant in late August, Shoiro saw opportunity among the destroyed machinery and damaged buildings. "We can rebuild this facility using American production principles," he told his father during their daily inspection tour. Standardized components, interchangeable parts, assembly line flow, semi-skilled workers performing specialized tasks. The concept represented a fundamental philosophical shift for Toyota. Instead of training master craftsmen to build perfect individual vehicles, they could train specialized workers to perform specific assembly tasks efficiently. Instead of hand-fitting components to optimal tolerances, they could manufacture standardized parts that were adequate for functional requirements. Instead of pursuing individual excellence, they could focus on system efficiency. But the transition would require abandoning manufacturing traditions that had defined Japanese industrial identity. Master craftsmen who had spent decades perfecting their skills would need to retrain for specialized assembly tasks. Precision manufacturing techniques that produce superior individual products would be replaced by adequate manufacturing methods that prioritize volume production. Quality standards would shift from optimal to acceptable. The captured American Bantam provided the template for this transformation. Its crude welds represented manufacturing techniques that could be performed by workers with minimal training. Its heavy construction used abundant materials rather than optimized engineering to achieve adequate performance. Its simple mechanical systems prioritized repairability and parts availability over individual refinement. American production philosophy suddenly made strategic sense when viewed through the lens of resource optimization and manufacturing scalability. Building adequate vehicles quickly was more valuable than building perfect vehicles slowly, when military effectiveness depended on equipment availability rather than individual unit performance. Mass production techniques that seemed crude by Japanese standards were actually sophisticated systems for converting available industrial capacity into maximum military output. The AK-10 program's failure taught lessons that would guide Toyota's post-war resurrection. Japanese engineering excellence remained valuable, but it needed to be applied to production systems rather than individual products. Precision manufacturing techniques could be used to create standardized components rather than unique artisan vehicles. Master craftsmen could train specialized workers rather than attempting to replicate their individual skills across entire production facilities. By 1957, Toyota would produce 100,000 vehicles annually using hybrid manufacturing systems that combined Japanese precision with American production efficiency. By 1980, they would become the world's third-largest automaker by applying lessons learned from the AK-10 program's mathematical demonstration of industrial warfare's fundamental principles. The company that couldn't build enough Jeeps to equip a single regiment would eventually build more automobiles than any manufacturer in history. The lesson of the AK-10 wasn't about failure. It was about understanding the difference between building better individual products and building better production systems. Standing in his rebuilt office in 1948, Kichiro Toyota kept the AK-10 prototype photographs on his desk as reminders of Japan's most valuable wartime lesson. Superior engineering applied to inferior systems produced strategically meaningless results. Superior engineering applied to superior systems would eventually produce both the most and the best vehicles in the world. In industrial competition, as in industrial warfare, the winner was determined by whoever learned to build systems that could produce the most of the best, not just the best.